Hello everyone, I am Shruti Joshi from the team Deep Drawing and my team members are Sneha Pandey, Ajit Kar, Amisha Rao, Akanksha Nayak, Nitin Aryan and Parvati Sharma. So today, me and my team will be presenting about application of machine learning in deep drawing process. So, machine learning is a subfield of artificial intelligence, which we also call as AI. Because of this, machine learning facilitates computers in building models from sample data in order to automate decision-making processes based on data inputs. Many technology users today have benefited from machine learning. Machine learning is so pervasive today that you probably use it dozens of times a day without knowing it. Many researchers also think it is the best way to make progress towards human-level AI. So, what's the need of machine learning? The machine learning field is continuously evolving, and along with evolution comes a rise in demand and importance. There is one crucial reason why data scientists need machine learning, and that is high-value predictions that can guide better decisions and smart actions in real time without human intervention. So, moving on to the goal of ML. The goal of machine learning is to build new and leverage existing algorithms to learn from data in order to build generalizable models that give accurate predictions and find patterns, particularly with new and unseen similar data. And the idea of use is each energy releasing event, called an acoustic emission, process an elastic wave, which can be detected by piezoelectric sensor coupled to the surface of the structure. AE signals emanating from such activities carry revealing information about the behavior of the structures, materials or processes. So, over to the next member.
Hello everyone. So now, let's discuss why we need machine learning in deep drawing. As you can see, that forming processes have a wide range of features and a monitoring system for this metal forming processes is required. Once a failure occurs in this process, a large number of defective products may be produced due to the fast processing speed. In order to prevent this, it is important to immediately stop the processing just after the defect occurs. The signal data using AI/ML, that is artificial intelligence and machine learning, has been often used for monitoring this condition in this process. The improvement of the data processing method and recognition rate is required in this process, and thus the machine learning approach is applied, which increases the efficiency and productivity drastically. Thank you. Over to next.
Thank you, Akanksha. Now we are going to discuss about the experimental methods by using artificial intelligence. So the first one is tensile test. In recognizing the forming state, it is necessary to obtain the basic data of AE signal during tensile deformation using a typical specimen. Therefore, a tensile test is performed by attaching an AE sensor to the material. The AE signal is measured until the specimen fails. The second one is deep drawing test. In the deep drawing process, the AE signal includes the signal which comes from both contact and friction between the workpiece and die. This means that the acoustic emission signal obtained in the deep drawing process may be different from that of the signal during the tensile deformation. Therefore, measurement of the AE signal during the deep drawing process are carried out, and the AE count is compared with those obtained during the tensile state. And the third one is recognition test. The AE data from the deep drawing testing system was used as the input data for the machine learning method. The AE signal was amplified by a tester and subjected to a high pass filter with a threshold value of 100 kHz. The count rate counted by the comparator was recorded on a PC via an analog input device at a sampling time of 10 ms. The number of data points per forming was set to 200 and 100 learning data were collected. Thank you. Over to next.
Thank you, Amisha. So we will be discussing about results and discussion about A characteristics and recognition test. A characteristic in tensile test. Next slide please. Okay, so figure 1 shows the stress-strain relation obtained by the tensile test. Dashed line in figure 1 show the location where the A count was used for the analysis. Two locations are chosen for the A count around the peak stress and the point of break. Figure 2 shows the A count obtained by the figure 2 shows the A count obtained by the tensile test. The vertical axis is the count rate and the horizontal axis time. Figure 2 shows the A count rate overall, the peak stress and the occurrence of break respectively. Figure 2a shows the A count rate at the transition of elastic deformation to plastic deformation. In relatively large, it becomes smaller at the peak stress and becomes larger again at the break. Figure 2b indicate that there are many peaks. Figure 2c indicate that there is one peak. A signals are continuously generated during plastic deformation and occurs intensively at the time of break. A characteristic in deep drawing test. Figure 3 shows product of deep drawing. From the comparison of workpieces in figure 3, the fringe area of cracked product is larger than the fringe areas of normal product. As a result, it can be confirmed that cracks occurred at the initial stage of the forming. Recognition of deep drawing state by machine learning. As shown above, forming state recognition should be confirmed. Therefore, recognition through machine learning was tested. The recognition rate by the combination of the activation function and the optimizer. These were the average values of tests performed 3 times. The horizontal axis is the number of nodes and the vertical axis is the recognition rate respectively. The optimizer tends to have recognition rate when ADAM is used. The highest value is 97.3% based on the combination with the activation function. SGD has the lowest recognition rate in combination with all activation function. The recognition rate tends to be low when using sigmoid as the activation function. Thank you. Over to Ajit.
Okay, Sneha. So as in machine learning, which is a multi-layered neural network, is implemented to recognize text during deep drawing processes. It is a new processing method which was proposed by using the count rate of A. Stress, A measurements during the tensile test show that continuous A signals are dominant during plastic deformation and it leads to short bursts of A signals. They get difference between the A count generated during the plastic deformation and the point of break. A count in the deep drawing showed that there are peaks caused by breaks occurring during deep drawing. Therefore, it is possible to recognize the forming state during the deep drawing by measuring the A count. That's all from our team deep drawing. Thank you.